lecture 6.2 of the lecture 6 series in Reducing Uncertainty will be about real examples. So we have given you background into how to categorize each of these innovation elements. Then we've talked about how they interact, and we've talked about how to reduce uncertainty. And so with these real-world examples, it'll allow us to go through and hopefully add those case studies, at least a couple of brief ones, to the first round of reducing uncertainty. I say first round because the next lecture is going to be about iteration. And so here we're just showing you how to reduce the uncertainty on what I would call the first pass. So one of the things that we wanted to do was just repeat the lessons from last time, and without going into detail, just kind of emphasize that here we're talking about the first pass, that we're talking about the first pass through looking at reducing uncertainty in market, application, implementation, and technology. And one of the things I want to point out, we always show the three element circles as being the same size. Of course, they don't have to start that way, right? You could have a lot of uncertainty in one area and less in the other, and you're kind of reducing one for quite a long time while you wait for it to finally get down to the point where it has to interact with the more narrow ways in which the other two elements are being restricted. So again, we're only talking about the first pass. And it'll be fairly easy because remember how these things interact naturally. So I think as we go forward, you'll see that this process, separating them is good initially. And then just understanding what the process actually is a huge benefit because the process itself is quite natural. So let's talk about the water initiative. This is the founding of a company in 2007 that I was brought into as part of the founding team by the main driver for founding the company was a man named Kevin McGovern. Kevin's idea in some broad way was looking at the big picture, the biggest picture of all, and saying, look, water purification is clearly an issue. Kevin has been successful in other parts of his career, and so it had a combination of not only being a forward-looking problem, but one that affected many regions of the world where people's lives were being affected quite seriously by the lack of water purification. Now, Kevin is his background is not technology so much; it's more in the legal, patent litigation, and actually some consumer product areas. And so when he approached me, we said, all right, that's fantastic. Now at the time, I became very interested for two reasons. One is it was likely that we're going to launch products outside the United States, and for me it would be the first innovation process where we would be working outside the United States at the customer end for right from the beginning. As you'll see later in the main example of this class, because the fundamental innovation, the amber wave systems, which was strained silicon, that was also global from the beginning, but it was more of a supply chain global, but a very U.S. dominated early adopter, at least at the end anyway. So it was attractive to me, and it was a different area of material science as well, where I began working a lot in technology related to semiconductors. This was new market space for me, as it was more involved with processing of water for purifying it. So it's also a good test of the innovation model we're talking about here, because it's the really one of the companies I founded with the innovation model already forming in our heads. We were already developing the background for Inside Real Innovation, the book at the time. So the water initiative started when a man named Kevin McGovern, who was another Cornell alumnus, approached me. He was on the trustees, and we were talking about different kinds of innovation work at Cornell at the time. And he approached me, and of course, the water initiative, as you would think, Kevin started with a big idea. He said, "Hey, water purification, water delivery to people around the world is obviously a growing market. It's going to be really important in the future. And Kevin had been fairly successful in the rest of his career, so he was interested in also doing something that was not only great for commerce and innovation, but also targeted, at helping a problem, because obviously water purification affects many people around the world, and with the knowledge in hand, one would think that there's some way to be innovative and to create essentially what could become the worldwide water company in the future. If you look at companies and the markets they serve, being a worldwide water company in terms of delivering water safely to people, there is no company that does that. A pure play water company, if you will, does not exist. We have in the market area, municipalities, right, which is in the advanced developed countries. They are big water, as we call them, but there's many different market applications. If you live like my house in New Hampshire, there's what's called point of entry systems, POE systems, and that's where you would have more like a people talk about micro energy environments and micro power, where you generate it more locally for a building or something like that. That's the equivalent. There's a lot of actually similarities in water to energy, in the sense that POE system is for a house, for example, so you purify the entire water coming into the house. Then there's things that are closer to the, as we like to say in the water initiative, closer things like point of use, or in other words, a little bit more accurate for breaking down this, because POE could be point of use to looking at it from a house perspective. But POD, which is point of drinking or point of use, point of drinking would be that you're putting the purification device right at the user, who's going to be predominantly drinking with water, not doing anything else with it. And so, there is this sort of background market application stuff that you could say we started certainly in this, water universe. And so our market application area, we didn't have a lot of detailed knowledge yet, but we had fairly good learning at the abstract level that was required just to get going. And so one of the reasons Kevin was interested in having me on the founding team was, of course, that we could bring the innovation and intersection of business through understanding also about technology. And so there are many different technologies that take place. Don't forget the municipalities. They have, drastically different technology than, let's say, a Brita water filter, which would be considered a point of drinking device, right? So again, the technology world is filled. And when we started, this is a new area. In fact, it's a testament to the innovation process we're talking about here, because my previous the water initiative was interesting to me in two ways. It allowed me to be involved with a company that was launching a product, probably outside the United States first, and it was also a different area of science and technology, where most of my other work has been, still is, in the area of semiconductors. Of course, the two are closely related, because actually water, it turns out, is, the key thing here is the processing of water, if you will, as opposed to the processing of semiconductor materials to create an embodiment that's useful in the marketplace. So it's not that different in an abstracted way, but still, every company and every innovation could be another learning experience, and that's one of the things that attracted me to the water initiative. And so one of the first things we did was, this time period was around 2006, 2007 when we started, and there was a lot of hype. There was to give you an example, a lot of hype around nano. The late 90s and early 2000s were kind of over, but there was still very much excitement about nano and carbon nanotubes. We're going to do everything from, cure cancer to make solar cells better. And so, of course, we knew from our model that wasn't going to be true, because making very, very specific, technology for a very, very specific end market when there's lots of innovation work to be done is probably not going to succeed. But this hype. The good news about the hype is it made everybody optimistic about new directions and things like water. And so, in terms of financing, which we did with angels, was an easier task because people are interested in solving the water problem. Plus, sort of this age was technology of any science will solve all problems. Now, we were smarter than that, so the good news is that we started to say, all right, we have to do our initial space, technology mapping space, and so we developed, we call our database, our technology database, and that database was used to start pretty much this iterative process with the market space we have over here. We'll get to the implementation in a second. And so, in collecting this database, we focused on a few things. One of the things we focused on was processes, because we realized that actually, there was only a certain number of processes you can do in a small volume. And here's where we're kind of leaking over into this area, because when I say small volume, we are, even though we're learning about these other areas, we're not really going to compete with municipalities and the massive infrastructure that we have to do there. We're going to work on smaller devices that can be deployed more easily and closer, if not directly, to the consumer. And so we concentrated on small volume, and then we thought about the processes that would be available in that small volume to tackle certain kinds of contaminants. And so, of course, in that process, there's different materials that can be used. And, I would say grouped in here, there's sort of mixed in certain kinds of devices. And, eventually we developed this pretty large database that, then allows us to think about, okay, fine, we kind of understand all of our options. Now, in here, there's a huge space. Don't forget about, future research. And, this would guide the company as we went through this process. We thought about what kinds of things are missing. And initially, it's not easier. But again, once you start interacting with market implementation, it actually reveals a little bit more easily what pieces are missing in here, what you'd like to see. And it turns out, as you would think in the water space, because it is important, there isn't actually, the good news for the company was that there weren't a lot of missing pieces in terms of, all the processes that have been possible for purifying water have been done. And a lot of the materials, even though some of them have been forgotten or not used that much in municipality purification, there's a lot of work out there and a lot of government support for work, because the municipalities work hand in hand, as you know, with the government in the United States, the local governments, to purify water. So there's a lot of publicly available information on water purification. So that was one of the first steps. Now in implementation, again, this kind of, structure of the industry sort of involves government. And so far, government has not been involved that much in a point of drinking, although one thing you have to ask is which government. And it turns out that very quickly we ended up deploying our first devices in Mexico. But of course, there's multiple governments depending on what area you're going to be in. And and government is always involved in water because it's sort of a national important good that people care about, obviously. So pretty much you're always going to have to deal with the government in some form or another, especially if you want to make claims of efficacy. So the other thing is structure of the industry. Like we said, the structure of sort of the municipality, government system, and also how the facilities are organized and created are pretty clear. It was also clear that was happening in most places in the world where our markets were likely to take off is sort of that I would say the implementation at the edges of the city was really not keeping up with the demand. So the population growth and things that are happening at the edge of the city and in different regions. Basically, the government in many countries, the government has a hard time keeping up with all the changing demands. And so the government wants to find solutions, and public-private partnerships are a way to go. And that, of course, was one of the things that over time developed for us, public-private partnerships, because it allows a government to innovate much more easily. Because when we finish this process, you'll see that innovation within the government is very, very difficult. So the public-private partnerships, and there's many, many things in here. One of the initial things that we were founded on was the idea there is something called a base of the pyramid. So the idea behind the base of the pyramid is that if you look at societies from a pyramid point of view, there's many, many people in the world making $1 or less per day. And so the idea is they will spend an enormous amount of their income to try to get clean water and other basic services, and that surely with some proper innovation model, we should be able to converge on that. And so that was there's a lot of overlap with ideas of co-developing technology and innovations being there in order to have what essentially we're talking about here is this innovation process work well. Because obviously, if you have a market application in a different country and you're trying out different technologies and you think about different business methods to do this remotely and not be there on the ground, or at least getting information from market implementation on the ground, is very difficult to have successful innovation. So in fact, TWI did this process and actually converged on its first product this way, which was called Water Cura. And essentially it was a sort of water cooler type thing, except the technology piece was that one of the biggest problems in the first area we deployed in the Central Valley of Mexico was that arsenic was the main problem. So as we iterated and we looked at the point of use devices, it became clear that application space where the point of view devices need to be used with arsenic started to be the convergence between market and technology affecting each other. And then it turned out that a combination of public-private partnerships developed later, but initially the base of the pyramid was the way that the product was first implemented. And we could describe later how all this worked, but at the end of the day, when these things were finally iterated, in the first session we had a technology that was a material basically, and a few other technologies in the device that took out arsenic as the principal thing, but did other things too. And again, without going into great detail, there's a couple of materials in there that we converged on. And then clearly the arsenic purification market, so it's a technology thing over here, but I'm putting it on the market side because it's the arsenic market that ended up being our big differentiator, because there's no solution in the marketplace. And then initially we ended up using the base of the pyramid protocol, which meant that you have people on the ground with you looking at business models that work in the local villages and local towns, and that is the implementation that's being employed. And so we actually were able to converge on our first Water Cure product this way. Now it turns out that we actually came back, opened up this process again, because a combination of changing to a slightly different public-private partnership and changing to a slightly different form of arsenic purification in the technology space ended up having us converge in a different area. So, going from here, to here in the end was at least the beginning of Water Initiative's first product.